So let's begin with our webinar. Welcome to our first webinar in 2021. It's a kind of magic. Here from System Verification, we're going to present today CodeScene, the crystal ball for your code quality. So what, in a sense, is CodeScene? CodeScene is a very strong, powerful visualization tool, which is really used for predictive analytics to find hidden risks and social patterns. To begin with, as already mentioned, my name is Moritz Barbarino. I'm a data analyst at System Verification here in Germany. And I've got more than 2 years of experience as an IT consultant in data analytics, quality assurance, point of sale software, and transaction management. I'm really passionate about data analytics, building dashboards, looking at requirements, how to formulate nice data strategy. And that's really what I live for. Wouter van Os, would you like to introduce yourself?
Yes, thank you, Moritz. My name is Wouter van Os. I'm working at System Verification since May 2019. Overall, I have 5 years experience in the field of QA as a QA consultant, and my main focus is in test automation.
Thank you, Wouter, for the introduction. Let's look at the agenda today. At the very beginning, we're gonna introduce System Verification and CodeScene. Then we're gonna look at some challenges in software development projects, and then it comes to the real part. It's a kind of magic. So we're gonna look at software intelligence, predictive analytics, use and benefits. In the second part, Wouter will share his live demo of CodeScene, presenting the tool, and at the very end, we're gonna look at a Q&A where you can then get answers on your questions. Let's look at who we are. We are System Verification. We are specialized in quality monitoring and data analytics, and our Swedish colleagues up in the north have been running this already for 17 years. They have done everything which comes into the origin of quality assurance. They've been really into every possible assignment, and they have numerous good clients available like HMN, Volvo, Alfa Laval, Swedbank, Scania Trafiken. And we followed slowly the journey. Let's look at our company as a whole. It all started in Sweden really 17 years ago, where then Bosnia came in as a second location. Just about 6 years ago, they opened an office in Sarajevo, where they then joined alliances in Germany and said, hey, we also need to open the market. And we've been 2 years in Bonn and in Frankfurt, and about 1 year ago, last year, we opened Poland, Warsaw, and we've been in total 17 years in business. The net revenue last year in 2019 was 200 million Swedish crowns, and we are a company of 250 people or employees. Let's have a look at our ecosystem. It is not just System Verification. System Verification is definitely the oldest companies, but we also have Impero, which is today known as CodeScene. CodeScene was founded 6 years ago and joined our ecosystem as a strong, powerful code quality tool. And reInvent is also part of our family, and they joined 2018. They have high passion for data analytics and software development, and I think all three corners, quality assurance, code quality itself, and data analytics really forms a good ecosystem. Let's have a look at the holistic approach on our quality assurance. Today, I'm going to focus mainly on the QA monitoring part. Since we're really digging into what CodeScene will be today and how this also relates to us, CodeScene is our partner, and we're offering services and licenses where you guys can really ameliorate your code and get a better understanding of your most critical areas and where to improve first and where to set priorities. And it's not just about analyzing and monitoring, it's also about the software intelligence behind it, having several performance checks, vulnerability checks, and other subscription-based profiles. I don't want to go into too much detail, but we as System Verification, we're also very strong in testing, and we have done everything from test strategy to test process to test management to automation to test deployment, and this is also a very strong point of us. Every business is a software business, And this is what Watts Humphrey said almost 2 decades ago. And why are we standing here? Because if you look at companies who are deliberately a software company today, there is no way you can really bypass your digital strategy in an era of digital transformation. You really have to work on your digital strategy, and there is no way you can cut over the digital edge. And this is something which Satya Nadella said, CEO of Microsoft. You really have to look into the future and see how you can shape your digital company. Let's have a look at the top technology trends. I'm going to focus on 2 corners today, the top left and the bottom right. And we also really want to be part of these trends. And what is really important here is that by 2022, at least 40% of new application developments will have AI developers and not as many software developers, and AI will really take over, and that will also be seen in development. By 2021, half of the large industrial companies will use digital twins, and this will really result in a 10% improvement in organizational effectiveness. Right in front of you, you can see a massive quality monitoring room. And this is the future we would like to also give back to our clients. And we really hope to also have this quality monitoring room in the future where we can really provide our services. And what do we essentially want to do different? I mean, you can already see here in the middle, there is a UI of the CodeScene interface, and it really puts out, okay, how many lines of codes they have, what is my complexity trend, and can give you really sort of a brief overview also about the hotspots they're currently facing. But what is it, what we really want to do differently? We want to combine artificial intelligence with human expertise, bring in quality analytics, and also provide data-driven insights, as you can see also with dashboards right here in the bottom corner. So quality monitoring, what for? Let's have a look at elite performers, but that's not the only thing on the slide actually. The scissor between elite performers and low performers is ever growing apart. And there's a huge gap between those at the very top and those at the very bottom. And it's not just about getting speed to market for quality monitoring, it's also stability, code deployments, teamwork. There are a lot of different aspects you have to think of. And it cannot be that elite performers deploy codes 208 times faster or have commits which are 106 times faster than low performers who just joined. And now comes a very important question. And I would like you guys to participate in this question and submit your answers in the chat. And the winner who has the closest number will win a CodeScene book. So the question is, if you look at quality monitoring and software development projects, how much time in percentages, and I really mean in percentages, is allocated to non-functional organizational tasks in software development? How high do you guys think it really is? So now you guys have the time to submit your answer in the chat. Right, last 10 seconds. All right, the answer is 70%. And 70% of the development time is really used for activities that are not related to functionalities. And I think 70% here is way too much. And I'm not saying that you can completely eradicate these 70%, but you can really reduce these operative costs by a huge fraction, maybe scaling it down to 30 or 40%, which is already a huge advantage for development firms and software firms. And I can assure you, with CodeScene, we are also able to close this gap between low and elite performers running this business. So challenges in software development. Everybody wants to be in control, have a scalable overview, wants to know how to really prioritize his development tasks, and also have a good distribution of overhead costs. And with these 3 pillars, you can really, CodeScene can really show you what sort of areas you need to prioritize, where you need to fix your problems first. And with this, you can really gain expertise. Users and stakeholders. Here on the very left side, you can see Adam Thornhill, and then right in the middle you see King Carl Gustav, and yeah, Carl Gustav decided to visit Adam Thornhill because yeah, he won an entrepreneur prize for his software, and putting it into the mechanism of users and stakeholders. Here, developers really get immediate feedback in their existing workflows, and technical leaders also have a better sort of idea of how to really supervise technical debt. And it is not just technical leaders and that developers get immediate feedback. You also have to take account the quality assurance and the test part. So you really have to make sure how to really detect delivery risks, prioritize testing, and where to define absolute quality gates. And with these quality gates, you can also move forward, making sure you can really get to your targets. And with that, the management has a very profound view how the technical leaders, the QA, and the developers are working together. Fact-based decision-making. It's not just all about that. Where is the actual magic? So it is a behavioral code analysis. And what I can tell you is the entire idea behind this is that behavioral analysis is basically merged with forensics. And with forensics, you can really point out where the hotspot or that specific point in the code is that needs to be improved directly. And I think looking at this picture, how do we come to these visualizations? Well, you need a source code. You also need version control data, and it's not just about the versionings, but you also need project management tools like Jira, Confluence, Bitbucket, name it, and to really sort of get that into the first layer to really evaluate the code and the process behind it. I think once you achieve that, you really have an idea of where basically machine learning is applied, which patterns are assumed, and with that, you can really get a bigger picture. And the hotspots in the center of the picture, with that, you can really drill down and also effectively see which areas are overfloating, which areas have high change frequencies, and you can really pinpoint also to the very right side what developer was part of which code, and which you can see in sort of that screen over there. And you can really see which developer has worked on which area of the code and which interactions were performed. Yeah, machine learning is a heavy part. And is it really black magic? Not exactly, but we're really, really close. And the good part here is you can really prioritize the hotspots based on different dimensions. Is it technical or social? But you can also predict various risks. These can be open risks, hidden risks, as well as CI/CD delivery risks. And the thing here about machine learning is that CodeScene has probably seen more than hundreds and hundreds of different code lines. So they were able to really predict with historical data, with a huge foundation of data, how the code and how a code in general can evolve. So with that much data, they were able to really pick up patterns and look inside to the code, understanding where these hotspots are reoccurring, re-evolving, and which areas are always in conflict. So having this large amount of data, you can really foresee And trust me, the tool has an expertise to really tell you how to prioritize hotspots. Let's have a look at the different offers we have. There's a health check, there's an analysis, and there's also monitoring. And let's start with the health check. The health check here is also the most affordable service we can offer. It's basically a health check report which does a very well-established analysis of your code. It points out which hotspots areas you need to work on. It will show you also a few details, and it really gets you into like a first sort of check how your code is performing and what to do. Going over to the analysis, this is very interactive. You will have interviews at the beginning, really, so CodeScene can really understand who you are, what you're bringing with you, what software you have in your back, and they really do an inventory check of your code. So this is really a profound established analysis, and this will be also guided with different workshops, which I will talk about just a bit later. We also have a very long-term monitoring activity, and there CodeScene is part from scratch until the end, where you can really establish a healthy code. And they really understand also your key issues at the beginning, and they can also predict and see and tell you if your code area is getting better over time, if your code area is really worsening over time. And they really have direct insights, and this is hands on hands, where you really will get a really detailed report as well. What is a health check? Yeah, I said it already, but just to add on a few things here, it really gives you a good overview of the software code and the code health. It will identify your hotspots, and you will get a report as a PDF. Going to the analysis itself, there you can really look into which KPIs are super critical, where to prioritize maintenance that is the most expensive. It really, what is even more important here, you will get a refactoring recommendation and also a report with these detailed findings, so you can really understand where to make your changes first with priorities. Going into the long-term perspective of project monitoring, it is really a continuous basis where you interact with CodeScene. And it also gives you information about a good test strategy and test planning. It also supports you on and offboarding, while also integrating it with CI/CD, where you can then analyze your risk prediction. You will also have a customized dashboard where you can really retrieve your different hotspots areas, where you will understand where to improve first, which you will see later in the demo. Transparency in the code. So what is exactly a hotspot? I talked about it just a bit earlier, a little bit, but a hotspot is really where the code complexity gets more and more and more over time. So if the code complexity gets more and more and more over time, it will also be more cumbersome and more difficult to change that part of the code later. Then you also have the code change frequency. So how many times was the code changed? Not that it just got more complex. And you can see here, the very white picture shows you a very low frequency, where the very yellow picture shows you a high frequency. And then forming code complexity and code change frequency together, you can identify a hotspot area. And there you will identify where refactoring is really of high importance. So what are our customers saying and thinking about CodeScene? Yeah, let's start with Whale-Shark. Whale-Shark is an M&A company, so basically they're in mergers and acquisition, and what they do is they want to evaluate their target companies they want to buy on. And they're using CodeScene to really understand the value of the software they also bring with them, these target companies, for them to understand what that firm is actually worth also in terms of their software. So it gives them even better sort of a better portfolio overview over their target firms, and they can also create better and more aligned numbers to reality into when it comes to their code, having a good price of the target company. We all know Philips. We all have maybe a light bulb behind us or a Philips TV at home. It's not a company without saying, yeah. They were really impressed how easy it was to set up CodeScene, how many detailed insights they were really able to grasp, and it really went explosive in terms of Philips at their company. And with that, they were able to solve one of the biggest bottlenecks in relation to code improvements. We also have Ucrude, a company, and I've talked about it just earlier, that 70% of the time you really look back on non-functional activities, and they just pointed out and they just put the finger right into the wound. Only 30% of developers' time goes to drive the product or the project forward in terms of functionality. And this really pinpoints it, I think. And they really bring in that you really need to refactor. You have to re-understand where to work on first. And with CodeScene, you can really increase your functional standpoint in a software. And they also said it will be Sweden's biggest next IT export, and this is absolutely true. They have CodeScene has already gone pretty wicked in the US market. They have attained numerous clients and also have a very strong position already in Europe with good feedback. And yeah, that's my side of the presentation. Now I'd like to jump over to the live demo where Wouter will now show you what CodeScene really is.
Yes, thank you, Moritz. I'm gonna share my screen just now. Yes. So I hope you all can see my screen. First off, before we really get into the CodeScene tool and really have a good look at all of the dashboards it has, I want to quickly take you back to school. And I want to point out the Leemann's laws of software evolution. So these are laws that apply to like almost all software development projects, and CodeScene really acts upon these laws, and especially the first two. What you can say is that a program that is used in a real-world environment always has to change to bring use to its users. You have to implement new features. You want to change stuff so that it becomes stays relevant for its users. If you have a stale piece of software, then over time people don't want to have it anymore. So for every software you have to constantly add things, add new features. With that constant evolvement also comes increasing complexity, because you add stuff, you add new code to it, so you always increase the software's complexity. So you really have to keep that in check, because if you let it go out of bounds, you will end up with a large amount of complexity where it's very hard to add new features. So your lead time to market becomes bigger, and obviously then your users don't want to use your project anymore. So this tension between these first two laws is really where CodeScene can help you in trying to reduce that increased complexity and really get grips on your software process, your software evolution. So that's the part where really CodeScene shines. So for example, if you see in your project that that releases become more buggy, and that the development becomes more slowly and also increasingly complex, then CodeScene could be a tool where you want to look at. So if you get CodeScene, then you have two versions or two options that you can use. You can use it as a software as a service in the cloud, or you can have the on-premise version. So install it on your own servers and run it really on your own infrastructure. Currently, the version that you are seeing is the on-premise version. I'm running it at the moment in a Docker container. And this is the project's overview page. So this is really your starting point in CodeScene, where you can see all of your different CodeScene projects. So as you can see, I already prepared a couple of them, most of them in the Bitcoin sphere. So I've analyzed the Bitcoin Core software, which is really the ledger software and all of the wallets. So really the open source Bitcoin software, and I've analyzed some open source wallets and also some an open source platform to building your own your own self-driving cars. So first thing I want to show you is how to create a new code scene project. So for that, you just click here on the plus. You get this view, and yeah, there you can create a new code scene projects, which you have several options. So you can specify your Git repos you want to analyze. So there's a various number of ways you can do that. You can have them, for example, locally on your server, or they can be in the cloud. So you can have a Git remote that you want to analyze. In your code scene project, there could be a several number of Git repos that all belong to the same code scene project. For example, if you're having a microservice structure in your software, and they all have their own repo, you can all put them in the same code scene project. So you can have your analysis really also on your whole wide microservices architecture. So we will just now start with analyzing a piece of software. 1 second. Yeah, so that's better. So I'm going to analyze this piece of code, which is a Python package. It's called Fast API. You can use it to create APIs, really fast APIs with high performance, it's easy to learn, fast code. So this is their GitHub. So you just copy their URL, go back to code scene, you specify your Git remotes here. So here you paste your URL, and then we have the options to add other repos. And once you're done, you have loaded all of your repos, you press continue. So now it's going to pull that repo, and it's going to store it in the Docker volume. So if I next, then you can add a title to your project. You can also have some other options here for how long back you want to start your analysis, and then you can create your project. Then you come into the configuration page, where you can have all kinds of config options. We will stick to the defaults for now, because CodeScene picks really sensible defaults, but you can alter a lot of things before you really run your analysis. So if you go back to the project's overview page, we now see that Fast API is here. It hasn't got any info yet because we haven't analyzed it yet. So to analyze it, you just click on the button Analyze, and in the background, it will now start analyzing this project. So at the end of the demo, we will come back to it, and we will see what CodeScene has done with it. All right. So from here, from this overview page, you want to drill into one of your projects to see its status. So the first thing you see is a dashboard overview page, where you have all of the key metrics that you want to see from your project. The first thing I'm going to do is move over to the scope, so we get an idea of this Bitcoin Core software. So for every analysis, you have in a scope some metadata about the project. So for example, its title, when it started, Bitcoin started in 2009, how long the analysis took, and also, for example, its file contents. So this project contains of multiple programming language, obviously, and if you look at the amount of files, you can see that C++ is its most important programming language. If you, for example, look at the amounts of the lines of code, then you see TypeScript and C++. So this is just to get a feeling of your code base. From, okay, what kind of files is it? What is it made of, the code base? Just to get a feeling of, okay, this is my code base. This is my project. Then you can see also some system trends, which are really nice to see. So this is your code churn. This is actually, you can see the heartbeat of your, let's say, the heartbeat of your project. You can see the number of commits in the blue line, and the number of authors in the red line. And something you can analyze from this view very simply is, if you, for example, have a big release coming up, you want to see the blue line going down, so that there's not much changing anymore in code, that the master becomes more stable over time. so that you are ready for your release. If you see a lot of changes happening at the last moment, you maybe want to say, okay, we're gonna wait with this release a little bit longer to make sure that everything is stable. So that's just quite quickly you can see from this graph. Then another interesting graph you can see is this change frequency graph. Moritz already mentioned it a little bit, is that in every code base you have parts of the codes where you more frequently work. So those are your hotspots, so to say. So this graph shows you on the x-axis all of your files, and on the y-axis you see your change frequency. So what we can see here, and this is something you see in almost all code bases, is that a small amount of your files is where you work the most. And that is really a starting point for CodeScene. For example, this long tail here is code that is there and maybe very important for your software as well, but it's not code that you change often. So it's very stable code, so to say. So if there's any technical debt in that part of your code base, then yeah, it's not beautiful, but it's also not very bad for your future development of your project. But on the other hand, if you have any technical debt in this small part where you often have to work and it is changed often, then you every time you touch that software or that code, you have to pay the interest rate. So you have to dig in, find out how the code works, see if it's complex. You have higher risk of adding, yeah, new bugs to it to mess up something there because it's such a complex code. So your costs become higher and your lead time for new features to market also becomes longer. So that's really where CodeScene steps in and says, okay, this is your business critical or business valuable code or stuff that you really have to change. So let's start here and find out if there's technical debt. Right. Um, so that's the notion of interactive hotspots. So first, next thing I always like to do is to go to this view, the interactive hotspots map, this style, where you can also see some nice figures that really say what's going on in your code base. So in this code base, CodeScene detects 5.2% of your code. It labels as red hotspots, so code that you change often. And 32% of all of your development effort is in this small amount of the code. And also 43% of your bug fixes are in this 5.2% of the code bases. So how can CodeScene tell you that 43% of your bug fixes are in that small part of the code? Well, every change, every commit that you do to the code base has this message, and CodeScene can detect certain patterns in this message. So the default to pick up bug fixes, so there's a default pattern CodeScene looks for, like defect and bug and whatever, and you can change that obviously. And then CodeScene knows, okay, there was a bug fix, so apparently there was in this file also a bug before. So you can also see your yeah, how many defects you have in your code base. So from here, I always like to go into the hotspot map. It's also a very good way to get a good feeling of your code base. So this is the interactive map. It's just to visualize your code base based on certain variables. So here, for example, we get an overview of the distribution of your hotspots. So the redder your circle is, so the circles are on file level. So the redder, the hotter. So the more change frequency there is, so the more it changes. So those are really hotspots. You can also see parts of the code with low code health. So CodeScene also can scan for code health. We will come back to it later, but you can see this is the status of your code. Low code health meaning red. And you can also see the defects distribution. So also in the red parts, you have the most bug fixes. So you can say also the most defects. So some other nice views is here, for example, an overview of your code health, where green is healthy code. Yeah, the other green or your blue is healthy then. Green is sort of a warning. It's not is not good, but it's also not dangerous yet. And the red parts are really parts with complex code and low code health. So these overviews I always use just to get a good feeling. You can also see, for example, here the technical sprawl, so the various programming language in your code base. So C++ is, for example, the pink ones, and green ones is Python. So you can see where are the files and what programming language do they have. So just to get a really a nice overview. So from here, if you go back to your dashboard, next thing that you want to do, okay, we now know where the hotspots are, where the most important or the most yeah, changed parts of our code base are. Next part, next step you want to do is to find out what is the status of that code. Is there any technical debt in that code? Because if it's healthy and you have to change it often, you're in a very good place, because then you can quickly add new features, bring new features to your end users. They are happy, you are happy. So then you're in a good spot. But if that's complex code, then you are in a more dodgy place. So coaching also gives you some tools to help you find out what the status of that code is. So for that, you go to code. There's a view here, hotspots code health, which prioritizes your hotspots based on its code health. You can also sort them by other metrics, for example, the number of commits, your code file name, but most sensible is to sort them by code health. So here you can see your hotspots. From top to bottom. So from top to bottom, you can see your hotspots, and then here you can see your code health. So CodeScene says that, for example, this file, validation.cpp, last year it had a code health of 1.36, and now it's got even worse to 1.29. So maybe you're asking, what does this mean, 1.29? So CodeScene measures your code health based on several metrics, which it calls biomarkers. Biomarkers are well-known patterns in code, or you can also say anti-patterns, that lead to an increase in complexity and also a difficulty in maintenance of that part of the code. So a lower code health makes the code more difficult to evolve. We can also have a look at those biomarkers. So here is a page where you have your analysis rules. So those are all of the biomarkers that CodeScene checks for in your code, and you can also put a weight on them. So for example, if you you can read here also what they mean. For example, brain method. Brain method is a large and complex function that centralizes the behavior of a module. The more complex the brain method, the lower the code health, for example. And you can put a weight on that. If you find it a very important pattern in your code, or something that you don't like to see in your code, you can put a weight between 1 and 10 on them. And CodeScene takes that weight and also takes it into account when calculating your code health. So here you can read on all of those biomarkers, and those biomarkers combined make up your code health. So now you know that CodeScene finds this unhealthy code. So next thing you want to find out, okay, what is actually wrong with it? You know, which one of those biomarkers are actually triggered or failing in this piece of the code? So for that, CodeScene offers you a virtual code review. So here you already gives a small tip here what's going on, but you can go even deeper. You can perform a virtual code review on a piece of the code, where CodeScene says really based on those biomarkers what is wrong with this piece of code. So for example, this file has a brain class. Now it always tells you where it is. Now it is the class and module design. Why it is a problem? So for example, here brain class is a module that does too many things and has too many responsibility. The problem manifests itself in a large module with many lines of codes, many functions, and at least one brain method. So it always tells you what is the problem. And here, for example, we have a brain class, so it's very large. It's difficult to keep in your brain, so to say. It also this class has a brain method and overall 155 functions. So you could say that it does maybe too much, this class. How can you fix it? So CodeScene always gives you a tip on how to fix it. So for example, for this particular case, it says look for opportunities to modularize the design. This is done by identifying groups of functions that represent different responsibilities and or operate on different data. Once you have identified the different responsibilities, then use this for your refactoring. So yeah, so those are CodeScene findings. They're all listed here. So some things that are really wrong and some warnings. You can either go one step deeper in analyzing this piece of code. If you, for example, do an X-ray analysis, so we now move from the class into the method level, and on method level you can also see which methods in this module are really the hotspots, have the highest change frequency. So for example, this exclusive luxury acquired, this piece of code is a hotspot in this particular module. And it has a cyclomatic complexity of 91, meaning there are roughly 91 logical paths to this method, meaning that you should have roughly 91 unit tests to cover all of the logic in this method. So you can imagine that if you want to change this piece of code, that it takes a lot of time to firstly find out what's going on in this method, and before you can really put your chains in that. So that is something that you can find out here. And then if you have done that, so you have found out what is the technical debt in this piece of the code, you have analyzed it, and you have come up with solutions, what you want to change to make it healthier, to make it better. You can then set a goal on it. So you can then really put a goal on it. If you're planning a refactoring on this piece of the code, for example, then you can make a ticket here to really plan your refactoring. What CodeScene always advises you is to make small incremental steps. So not make try to get rid of all of the technical debt in once, because that will be a large merge and it also brings its own risks. So really take small steps and trying to improve your code health step by step. But CodeScene offers you really like targets you can set on specific files to really make your improvement actionable. So there are different kinds of goals that you can set on. This one speaks for itself, planned refactoring. And you can set some text here, what you want to change in this next cycle. You can also choose to supervise this hotspot. Supervise means that the code health is now acceptable in this hotspot. So for example, it has a code health of 8 or 9. But you don't want it to get any worse. So if you supervise it, then CodeScene in the next analysis will give you a warning if this piece of the code gets a lower code health. So your changes lead to lower code health, meaning you took on some technical debt. You can also say this piece of the code is no problem, meaning that it could be that CodeScene gives you a false positive. It could be the case, but it also means, for example, from the context of your software project, you know that this piece of code will be gone in 2 weeks and it will be replaced with something else. Then you can say it's no problem, and CodeScene doesn't track it anymore for you, doesn't give you any warnings on it. Unless something really drastic happens. So if something really drastic happens, code health goes from 10 to 1, then it will still give you a warning. You can also put a label on it that is critical code, so it's very critical for your business infrastructure. And then it will come into a separate view where you can really track your critical code and the status and code health of that. So that's the second part of the workflow, as you can say. So you have looked into all of your hotspots. You have seen what is the technical debt there that CodeScene tells you. You have done your own analysis to see what you can do to change it, to make it better, to fix it, and then you can put a goal on it. So if you're done with all of that, CodeScene gives you an overview of your goals. So every analysis, it will give you some warnings on your dashboard. What is the what is the status of your goals, and gives you a thumbs up if you're doing a good job, your code health gets better, gives you a warning and thumbs down if your changes lead to an increase in technical debt. So you can go into CodeScene for every analysis, after every change that you made to your code base, but it's also an option, and it's obviously a better way to integrate CodeScene into your software development process. So you can integrate CodeScene into your CI/CD pipeline so that you get quick feedback on every change that you do. So every change set that you make, CodeScene makes an analysis on this change set and gives you some heads up on what's going on and some warnings, so you can really integrate it with quality gates. For that, you can, for example, integrate it with your pull requests. So it integrates with all of the major platforms. For example, you can integrate it with GitHub, with GitHub app, with Bitbucket, GitLab, Azure, and Gerrit, for example. And what it does, it runs a delta analysis. And a delta analysis is the following. I will quickly hop over to the documentation. The purpose of a delta analysis is it prioritize your code reviews based on the risk of a commit. It specifies the quality gates for your goals that you put on your hotspots. Specify also quality gates that triggers in case code health of a hotspot gets worse. And it gives you some early warnings when you add new code, which is complex, and it also detects absence of expected changes that might indicate bugs. So that is the feedback that you get when you integrate it into your CI/CD pipeline. So that's the first option, to integrate it into your pull requests. There's also a second option. CodeScene also has a API, so you can also send some data of your change to that API, and CodeScene gives you the results of the delta analysis back. So you can integrate it into your own process with this API. And the third option is there is an official Jenkins plugin, so you can also use that if you use Jenkins in your CI/CD. So how does that look like if you see it in real action? So I've analyzed a couple of projects here, and there is one of them that is really actually already has integrated CodeScene into their development process. And if you look at the code health of the project, you can probably guess which one that is. It is this Wasabi wallet. It now has a code health of 9.2, which is quite high. And I always like to think that that is due to the integration they have with CodeScene. So we can have a look at their GitHub to see how that looks like. So this is their GitHub. It's also an open source project, and this is an overview of the pull requests that they have. And they have integrated CodeScene with the GitHub checks. So for example, if we go to the latest change that they made, we can see they have set up 4 checks. One of them is CodeScene. This one, all checks are checked, for example. So this is then the pull request comment that CodeScene gives you. It says, or your quality gates are good. So meaning that the goals that you have set are not violated. So that the code health in this goals that you set hasn't got worse. Also that any other part of the code of your hotspots doesn't get below a certain value that you set for code health, for example 8. So it gives you also a warning on that. And it gives you a recommended review level. So for this specific change, it says you only need to do a lightweight sanity check. So based on that, you can also, because if you have a lot of pull requests and you have to review everything, it also takes a lot of time to review anything. So CodeScene gives you like a recommended review level. So here it says you only have a lightweight sanity check. But if the change is, for example, larger, I have to tell it differently. It bases it on the risk of the change. So you have CodeScene knows about all of the changes that you have made into your code base, and it knows, or it calculates how an average change in your code base looks like. So how many lines are changed on average, how many different developers change it on average, and does the developer who changes the code, is he already a long time in a project or not? So based on these three metrics, um, CodeScene sets a risk on your change, and if it's high, then you should really review it, and if it's a low risk, then you should not review it or do a light sanity check. So, for example, if in the Linux code base, Linus Torvalds made a large sweeping change, obviously you have to check it because it's a large change, but yeah, Linus Torvalds is the founder of Linux, and for example, if I make the same change, I've never worked in that code base, it's obviously a higher risk. So that's also something CodeScene takes into account when giving you this recommendation. So this is all good. Obviously, we want to also see one that has failed. I'm just going to try and find one, and if I don't find one quick enough, we can go over to one of the screenshots. Yeah, let's go over to screenshot I made earlier. So for example, here you can see that the CodeScene checks failed, not based on its quality gate. That was all good. But there is a larger recommended review level. It said so you should do a detailed review on this change set because there's an increased risk of defects. And then the reason is the change involves more modules and modified lines of code than 99% of his historic high-risk change set. So there's more code changed and more modules. So it's a sweeping change, large change over various modules. The risk is lower since it is an experienced author responsible for 30% of all changes in his repo. So based on that, you have your data and you can decide yourself how far you want to go with your review, but this is what CodeScene tells you what you can and maybe also should do. So that's really the whole workflow, how you can implement CodeScene into your software development cycle. So you can hook it up to your repo, then you can start your analysis. There you can look at your hotspots, find out what the hotspots are in your code base, see where they are. Then next step is you dig into those hotspots, really see if there's any technical depth in that, and really try to find out and analyze what you want to change to make it better. Then you can set some goals on it to really track if you are improving on those hotspots or not. And then next step, you can integrate it into your pipeline to have your quality gates really set up, and also to get quick feedback on if your code health or your technical depth is improving in your code base. So that's really the main workflow of CodeScene. Then there are also, if you have set that up, everything, there are some other things that you can do. So more advanced analysis that you can do. Because now we have looked mainly at the technical side of things, really on the code. But what also is a very plus point of CodeScene is that it also does not look only to your code and your technical side of things, but it can also do an analysis on the social side of things. So for that, I'm gonna move over to the Toku. So how is the social side of code relevant? Software development at scale is mainly a social thing because you work in teams, sometimes distributed teams, and need to communicate and coordinate to solve your tasks. So then there is this notion of process loss. So if you work in teams, or if you have to work with other developers together, you have this notion of process loss. So in the mechanical world is all of the energy, if you want to make something, it's all of the energy that get wasted on friction, heat. So energy that you not use to really make the thing that you want to make, but energy that you lose, because you have to yeah, because you just get lost in the process. So that's also with software development. If you have to coordinate your efforts very much with other people working the same part of the code, or with other teams that are maybe working in a different repo or in different parts of the code, then that's also process loss, which means you cannot get your features quick enough to the market, and it also costs money. So CodeScene can also give you some insight into the social part of the whole software development process. And we're gonna just show you some various screens from CodeScene where you can get some insights into those aspects of your code. So for that, you have here in the menu team dynamics. For example, this view, you can have a overview. So again, this is an overview of the main authors of every module. So these are all your active developers at the moment. Active developers meaning developers who made changes in your code base the last 6 months. And here you can see based on color who is the primary author. So for example, in this part of the code, you can see that Vladimir van der Laan has written 86% of this code. So this is again just a view that you get a feeling. Okay, yeah, who is the main author and how is it in my code base? If you have set up teams, that's also a different option. So you can, if you work in teams, for example, on a software project, you can put your individual developers in the various teams, and you can also have a view on this for your teams. So because it's an open source project, Bitcoin Core, and I've I don't know if they work in teams, so I did not set it up for this project. But you will get the same view then based on teams. So what you can then see per module is that if you know that that module belongs to a certain team, you can also see if that team really has a mastery over that piece of code. So is it really the owner of that code, so to say. So that's a view that you get a broad idea on this code. Then you have, for example, this view, which is knowledge risks. You have several colors. If there was a red color, it would say knowledge loss in complex hotspots, meaning it is a hotspot, so code that you change often. It's complex, meaning it has a low code health, and there's a knowledge island. So knowledge island means that um, there's only one guy who has all of the knowledge in this module. So that's a risk, obviously, for your project, because if that guy runs under a bus or he gets sick or he just leaves, then you have some complex code which you have to change often, which you have no knowledge over in your team. So what you can do then to mitigate this risk is you can onboard some other developers in your project on that piece of code to share knowledge, to try to spread on the knowledge based on that. So CodeScene gives you just the insight on where are those knowledge risks and islands in your code base. Then obviously you also have some knowledge loss. If your project just goes on long enough, people leave and they've written code which they maybe did not put in Confluence or any other docu they've written, so you have some knowledge loss. Here I already tagged some of the developers as XD developers, so then CodeScene gives you an overview on where that knowledge loss is. So with the current set of active developers over the last 6 months who have made change to their code base, they have not written anything in these parts of the code. So that those are really, and you can plan them. For example, if you want to plan a new feature, want to change, then you can look at this graph and say, okay, we want to really make changes in that part of the code. We have no knowledge there, so maybe we should spend some more time on this feature. First part is to really, try to dig ourselves into this piece of code to find out what it does, how complex it is, just to get a feeling with the code, and then next part we can really make the changes and get the features to the market. So you can plan a bit and not plan it, try to think that you know everything, plan it, and then afterwards say, hey, that took a very long time, that's very strange. So you can plan your project a little bit based on that. This view is really what shows you the process loss. So the redder the circle, it has more coordination needs. Coordination needs meaning that it has a high fragmentation. If you see, for example, how many authors have worked on this piece of code, So the knowledge is spread over very many people, and also very many people have to work simultaneously in this piece of code, meaning that you can have risk as yeah, um, for example, feature interactions that you did not know about because people change things in the code that you get feature interactions, which are maybe results to bugs. They have to maybe some merge conflicts that you can have, which also leads to bugs, and yeah, it's just process loss. So it's you cannot put your full effort into making new features, but you have to coordinate your efforts with a lot of other people, which leads to this notion of process loss. So here you can really see in your code base where that might be a problem in your code base. So that's on the individual level. You can obviously also have that on a team level if you have made teams in your project. Some other thing on the social side that I can show you is social networks. In this Bitcoin project, there are no social networks, so I'm just gonna move to the documentation quickly. So social network is really the notion of Conway's law. Conway's law says that a project works best when its organizational structure is mirrored in its software. So if you, for example, have set up teams, so everyone works in their own teams, you really want to see the most interaction within those own teams. This again is a notion of process loss. So a social link, people get a social link if they made a certain amount of changes in the same piece of the code. So for example, Grete Karlstad and Mike Johnson have a social link because they work in a piece of code. They have made, for example, more than 20 changes in the same piece of the code. So they have a social link. It's likely that they have to interact and coordinate their efforts. In a team, normally that's easy because you're in the same team, you have the same context of the code, so you can you know what you're talking about, and it's more easily, and you have short lines. But for example, if the integrations teams has to coordinate a lot with the core team, maybe that's in a whole different country, even if it's in a different repo, then you will have again process loss. So this is a pattern you would like to see in your code. If you do the analysis and you see a pattern like this, for example, then you know, yeah, you have a lot of time is being wasted in interactions between different teams. Right. So here you can get insight also on social side of your software development process. So yeah, I think we are then at the end of the demo. Now, one other thing I want to see there, want to say, there's also like a distal, which is the it also has to know with has to do with the knowledge. It says that 43% of the code is written by only one person, so that's also in this project a big issue, and 16% of the code is abandoned. So what you can do based on that, or code team can do, if you know that someone is leaving your project, for example, you can simulate what the effects on your code base are. So for example, if Andrew Chows says, okay, I'm going to work on some other project, I'm going to leave Bitcoin, then you can say, okay, what risks do we have? Then you can see here that the red parts will be knowledge that will be lost because he has written most of the code. And then you can also make actions to mitigate this risk. So you can, for example, onboard someone else, have him document his piece of the code, let him share knowledge and whatsoever to really try to reduce this risk. So that's something else that Codeteam offers you. So to wrap up the demo, we have seen how you can load up a new project, which we have done with Fast API, for example. So now this one is ready. So you can start digging in with this. If you see at the analysis data, it took only 27 seconds. And it's a code base. It's not a really large code base, I would say. What is it? Maybe 60,000 lines of code. So, and then you have all of the infos and you can make your actions and try to make it better and healthier. So we have seen this workflow, how to integrate CodeScene into your development process with the major platforms like GitHub, and get quick feedback. And we have seen, besides the technical part of the code, we have seen also some social analysis you can do to see if you can improve on the social side of your software development. So with that, I think that was the end of the demo. And if you have any questions now, I think we can start the Q&A session.
Yeah, thank you, Dr. The demo and showing how it's easy. So let's go right back to the Q&A part.
I think so you can put your questions into the chat if you want, and we will try to answer them. Let's see what we have. Does CodeScene development team use CodeScene in their own development process? Yeah, so that's also a main learning of CodeScene itself. So CodeScene, obviously, it's also itself a software project. It's not open source, but they have obviously their own source code, and they also use CodeScene on their own code base, so they can learn also, and they can fine tune it based on their own code. And obviously, they also want to have their users make new features for their users, so they implement CodeScene to also get quicker feedback on the health of their code and get features out quicker. So yes, that's actually a great learning for CodeScene itself as well. So you can also say they eat their own dog food. So yeah, I guess there are no other questions. Then if you would like to know more and see more about CodeScene, obviously also in the invitation there was already a link to their website, so you can always check out their website. Adam Tornell, which is the founder of CodeScene, writes a blog also on their website. So sometimes when there's a new feature coming up, or sometimes I think once a month he writes a blog about what he is thinking about in the space of CodeScene. So if you want to follow it, I can really advise you to read this blog sometimes. There are also some videos on YouTube which you can see how to do different things. There's another question. Do you have any experience with workers' council regarding the feature when someone is leaving? Not sure if I understand the question 100%. With workers' council, especially regarding the feature. I think workers' council, I don't, maybe I can unmute you. Oh yeah, the betriebsraad in. For myself, I don't have. But yeah, you can now see at least, okay, he is leaving the project. Maybe you can set up a rule in your company that if someone is leaving, we have to do this check, and then he has to leave in a good fashion. So you for your company, you don't have to risk. Maybe you can set up such a rule in your workers' council. Success work, yeah. I don't know if I understand the question 100%, but yeah, it just gives you some insight. So if you don't have codes in you, it's hard. It's very difficult to find out where your risks are in your code base or in your software project. And with codes in you can have this insight at least. And what you do to it with it, it's obviously up to you or your company, how you act upon it. But CodeScene gives you the data, how it looks like, and how you act upon it. You can decide for yourself. But yeah, that's maybe the thing you are after. In your analysis now, you see a lot of these names, obviously, right? So you can see especially which part of code, and you can also mute that. So you get some metrics. You can see where the hotspots are, what the code health is, but you can also leave this this personal data who changes what, you can also leave that out. So that's also an option. Yeah. I hope that answered it. I can actually show you how that looks like as well. I have to share again. 1 moment. It is still shared my screen or not? No. All right, I'm going to share it again. So yeah, you can see CodeScene again, I guess. Yeah. So for example, in the Bitcoin project, how you would do that is you go into your config and you have your demo features, and then you can anonymize the analysis results, makes file names and others anonymized in the analysis results. So if you save this, maybe we can do it on a little bit smaller code base. Fast API is pretty quick. So you go to demo feature, click this, go back and start the analysis again. Okay, now there is, now you individuals. Yeah, yes, there was also some error. So maybe it's because you have to put it into the first analysis, because now already it has the data obviously from the first time you've done it. So, but there's definitely the option to leave the names out of it. So you cannot trace anything back to the person who has written it. It is possible, yeah. Does it have scope for procedure language analysis for database code bases? Right, so if you go to the documentation, this is the documentation that you get. You have here these supported programming languages. So, so this is the coverage of the different languages that CodeScene can analyze, which this is the list. And if there's anything with databases, so you have Oracle, PL, SQL, it says no, yes. And what does that mean? It doesn't have full support, but it has X-ray, so you can analyze it on a method level. So there is some support for database languages. So here you can obviously see the list. It is also work in process, so we continue to add support for more programming languages over time. As always, if you lack support for a language, let us know and we will make it happen. So if you, for example, have CodeScene and there is some exotic language that you use that is not supported by CodeScene, it's work in process CodeScene, so they constantly add new languages to it, to their analysis. Yes. Do you have an example of how PRCheck's integration looks like for Bitbucket? GitHub has a check section by default. Not sure how it would look like for Bitbucket though. Unfortunately, I myself are not really well versed in Bitbucket. I have actually not seen it a lot. There is this integration, and I guess it would look something the same. It gives you at least the same info. So this quality gates that are checked upon. So it gives you on your goals, and if any code health in your hotspot gets worse, it gives you that feedback. At least it gives you the risk. So if the change is more risky than other changes, it gives you recommendation for your review level that you should do. So this info is the same over all of the different platforms, and I'm not sure how it looks like at Bitbucket, but I guess you can also integrate it into your pull request there, and it's done by hooks accepting, and you can set up webhooks. How to set up this integration with I can show you how to set it up, but I cannot show you how it looks like in Bitbucket. But if we go back to CodeScene, you have your documentation, your PR integration, and then you have Bitbucket. So you have to give it your username and your passwords. specify the Bitbucket API URL. If that blank default API URL is constructed from the repository path, and this is then the Bitbucket webhook URL, and save it. And I guess it should show up on your Bitbucket, but I cannot show you, and I don't know exactly how Bitbucket looks like. So, but it's sort of the same for the different platforms. So, for example, GitHub, you just also give your credentials there. Also sets up a webhook for you. But you can also read how you have to do that, everything here in the documentation. So that's really well written down, how you set up this various integrations. For example, your Jenkins plugin, if you use it, and all that kind of stuff. But I cannot show you now. No. All right. There's also one other thing I maybe would like to mention. Besides the PR integration, so into your pull requests, you can also integrate it with your program management tools. So for example, Jira, Trello, Azure DevOps, and GitHub Issues. The analysis you can do when you set up us is, for example, you can make a cost model of your different modules. So there are in Jira, for example, there are different types of tickets that you have: user story, bugs, all the kind of stuff. So you can say, okay, this is planned work, this is unplanned work, and then CodeSync gathers the data as well. What kind of work is done in a specific part of the code, and you can say, okay, in this module we have, for example, 81% planned work and 18% unplanned work. If you see in your modules that you over time have a big amount of unplanned work, so that it takes longer, more user story points, or more time to get a feature in that code base, it could also be a sign that you have some excess technical debt in that piece of the code. So you also, especially for managers, that could be interesting to see, because they always say management from, hey, it takes a long time for this feature, for example. And if they see, okay, it takes a long time because there's a lot of unplanned work, you can schedule some time in the next cycle to really try to refactor that part of the code. So in the future, if you plan something to add a new feature to the parts of the code, you are more close to your planning, and you don't have so much unplanned work, which is always nice for management, that they know, okay, we're gonna invest this amount of time, this amount of money in it, and we also know that feature will be done by then. So that's also some views that you can have if you integrate it with your Jira. So that's also some other nice feature. Yeah, so for now, if there are not any other more questions, yeah, then I would like to thank everyone. Like I said, you can go over to the Ampere website, which is the coaching website. You can see how it works. You can read some reviews from people who already have integrated it. You can read the blog of Adam. You can see what kind of options there are if you want to buy it with the cloud version, the hosted software as a service, the on-premise version. And if you have a larger enterprise, then you can get in contact with CodeScene to see what the options are there.
Right, thank you, Walter. I will definitely close off.
Okay, then everyone, thank you for your time. Thank you for listening. I think Moritz wants to say some closing words.
Yes. Yeah, so thanks again for coming in today. Just to quickly point out the different users. Yeah, And for further information, yeah, we have these books here by Adam Thornhill. Wouter already mentioned a few, and I really advise you to buy Your Code as a Crime Scene, or also Software Designers X-Rays. We have really good customers reviews. Make sure you have a look into that. Also, how you can really do your unplanned vs planned work, the technical debt, and the migration to microservices. So thank you again for your interest. Yeah, my computer just had some technical issues, not sure what happened. But thanks again really for being here. My name is Moritz. Wouter did the presentation of CodeScene, and I hope that you guys really enjoyed the webinar. Yeah, thanks for coming.
Thanks also from my side. Thank you.